Hi friends, in this session we are going to derive the expression for 1 degree of freedom system by using the energy method. So for this one we will consider a spring mass system. This is the spring, this one is the mass. Spring mass system. And for this spring mass system, we are going to determine the equation of a differential equation, and then we will determine the natural frequency. So to determine this one, initially we will have to know the energy which is stored in the spring when it is elongated. So consider this mass, when I apply any external force, then it will displace by x. So during the displacement, this spring will elongate, and during the elongation of this spring, the potential energy will be stored. When it will reach to this extreme position, this potential energy will spring back this mass to its original position. So this mass will move in backward direction. Means the potential energy stored in the spring is converted into the kinetic energy. Again, the kinetic energy will convert into the potential energy during the compression, and this cycle will repeat. So in short, during the extension of spring, the potential energy will be stored in the spring, and then that potential energy will spring back this mass to original position, and during that it will be converted into kinetic energy. As per the energy theorem, the energy present in any system is constant, and in this system we have potential energy and kinetic energy, and the total energy of the system is constant by using the energy theorem. This is the conversion of energy in spring mass system. If I consider one pendulum, suppose this is the pendulum with this bob, that is ball attached to this string. This is the original position, angular displacement is theta. Then suppose this is the datum where we consider height is equal to 0. Now here in this position we can say that the mass is lifted to some height h, means the potential energy will be stored here, and that potential energy is nothing but mgh. Okay, so potential energy will be stored. Now when this mass is going to move in this path, then this potential energy will be converted into kinetic energy. Here the total kinetic energy, the total potential energy will be converted into kinetic energy. So here in this point we will have maximum kinetic energy, because the potential energy will become 0, as this is the datum point. When this will reach to this extreme position, again the kinetic energy will be converted into potential energy, that is mgh. Again when it is going to move back, then this potential energy will convert into kinetic energy. Again here the kinetic energy will be maximum, and at this end the potential energy will be maximum. So there is conversion of potential energy into kinetic energy and kinetic energy into potential energy. If we take any intermediate point, here we will have potential energy plus kinetic energy, and this summation will be equal to the total energy of the system. Means in extreme position we will have maximum potential energy which will equal to the total energy, and in this system, in this position, that is the center position, we will have maximum kinetic energy, means it will equal to the total energy of the system. Means with the energy theorem, if we consider the spring mass system or pendulum, the potential energy plus kinetic energy will remain constant. Now to solve this one, here I am going to write the potential energy stored in the spring. So as we have seen in machine design, in the spring topic, the force acting on the spring is directly proportional to the displacement. So this is the spring law, that is force is directly proportional to displacement, and as it is directly proportional, so we can show by using this graph, that is the straight line passing through the origin. Now if I want to calculate the energy stored during the expansion or elongation of spring, this is the energy stored in the spring, and this energy is nothing but the area of this triangle. So area of this triangle is 1/2 base into height. Now as this is 1/2 base into height, that is 1/2 F into x, but the spring force is nothing but kx and this x. So the spring force is kx. So the total energy stored in any spring will be 1/2 kx square. So I am going to use this one in our derivation. So I am going to write the potential energy stored in the spring by using the spring formula from the machine design. It is 1/2 kx square plus the kinetic energy. Kinetic energy is nothing but 1/2 mv square is equal to constant. So potential energy plus kinetic energy is equal to constant. Now I will modify the given equation. So 1/2 kx square plus 1/2 m, velocity is nothing but x dot, that is the differentiation of displacement with respect to time, that is the first differentiation. So I will represent the velocity as x dot is equal to c. Now this equation is potential plus kinetic is equal to constant. Now differentiate this equation with respect to time. Differentiate with respect to time. So after the differentiation, this equation will become the half is constant, k spring stiffness is constant, and this x, it is 2x, differentiation of x square is 2x into differentiation of x is x dot plus 1/2 m, this one is constant. Now differentiate x dot square, so it is 2x dot into differentiation of x dot is x double dot is equal to differentiation of constant is 0. So this equation will become, after the differentiating, the first differentiation 1/2 k is constant, differentiation of x square is 2x, and the differentiation of x is x dot plus 1/2 m is constant, and differentiation of x dot square is 2x dot into x double dot, that is the d2x by dt square. Now take the values which are common. So first initially we will cancel this 2 with this 2, this 2 with this 2. Now here we have x dot and x dot which is common, so I will take x dot as common. So the remaining thing is k x from the first term and from second m x double dot is equal to 0. So transfer this x dot on the right side, so the equation will become mx double dot plus kx is equal to 0, and this is nothing but the differential equation of vibration. So this equation is differential equation of vibration. So as in the derivation they have mentioned that write down the differential equation. So this is the differential equation. Now we know that any vibratory motion is with SHM. So I am going to write here the differential equation of SHM. Now the differential equation of SHM, as we have seen earlier, it is x double dot plus omega square x is equal to 0. Now compare our equation with the differential equation of SHM. So to compare this one, I am going to modify this equation. So divide by m. So this equation will become x double dot plus k by m into x is equal to 0. So I have divided by m throughout this equation. So mm will get cancelled, here k by m and 0 by m. Now compare with the differential equation of SHM, because the vibratory motion is with the SHM. So compare with differential equation of SHM. So after comparison, here you can see it is x double dot, x double dot. Here you can see x, x. On the right side it is 0. Means ultimately this omega square will be equal to k by m. So omega square is equal to k by m. Means omega n natural frequency, circular frequency will be root k by m. Okay. So this is the value of omega n. Now if you want the time period, then you can write the time period as, means time period required for the vibration. Time period is nothing but time required to complete one cycle. So Tp will be 2 pi by omega. So we can write 2 pi by root k by m. So this is the time period. And if I want the frequency of vibration, then frequency will be 1 divided by time period. So it will be 1 divided by 2 pi divided by root k by m. So I will transfer or modify this one. So it will be 1 divided by 2 pi root k by m. And this is the frequency. Okay. So this is the frequency of vibration, and that we have determined by using the energy method. So this is the simplest method to determine the natural frequency. This is the simplest method. Okay. So I'll revise this one. See, for any system, the energy by energy theorem, the total energy on the system is constant. Here we have seen for the spring mass system, the energy will be transferred from kinetic energy to potential energy and potential energy to kinetic energy. For this pendulum, it will be converted to potential to kinetic, kinetic to potential. Okay, and when we convert this from one form to another form, then potential plus kinetic is equal to constant. Potential 1/2 kx square, kinetic 1/2 mv square. V is nothing but x dot. So I have differentiated this equation with respect to time. Then I have taken x dot common. Then I got the differential equation of vibration. So after getting differential equation of vibration, we have compared with the differential equation of SHM, and by comparing it, we got omega square is equal to k by m. So omega n is equal to root k by m, and from that we can determine the time period. 1 by Tp is equal to 2 pi by omega, and the frequency is nothing but 1 divided by time period. So here I have just given the value of Tp. So the frequency is 1 divided by 2 pi under root k by m. This is the derivation by using the energy theorem. Thank you.